Good morning to you all. Glad to meet you. Glad to see you. If you came in here looking for nice examples for your next code reviews, that might not be the right place, which you could probably gather from the title of the talk. So, I'm one of the committee members who've been with CppCon since the beginning, and this morning I'm going to make my reputation go down for sure with examples of code that you might not see every day, or might rather not see, but I think it's going to be worth it anyway. There are many things that we teach. I'm a teacher, that we teach without thinking, that we teach because we've been taught. We've been said this, and we've been told this is good, this is bad, or something, and we take something for granted. And I realize that when I go visit my intern students, they work at shops, and people have practices that have been established, and nobody remembers why, but they apply it, and that's okay, right? It's rules. They take that as good practice, and such things sometimes comes from the so-called wisdom of the ancients. Some interesting and bright people have said, this is the way things should be. And sometimes, well, oh yeah, that makes sense, and we go along with it, but then we stop thinking. So we have this kind of mythology as to what good practices are, which is in good part a good thing. Now we are a young science, and we're lucky some of the ancients are still among us, or have died only recently, and we take part in something really, really cool. We're very lucky to still have ancients among us. Some of the bright people in the building right now are incredibly nice to know. Since, well, it's a science, and our ideas evolve, and our languages evolve, sometimes it's interesting to revisit some of the so-called wisdom that we have, because some things that were good maybe in the 60s might not be so good today. It's worth thinking about it at least. So let's do so. In particular, C++ has changed quite a bit over the last few years, last 10 years or so. And yeah, it's different enough from the language that we used to have, such that the practices that we had might deserve a second look sometimes. I'm not saying it's always a good thing, but let's take a look. Such things as goto considered harmful, which is a very widely circulated paper. Only one return per function is something that deserves attention. I know that my school still teaches that. I'm not sure it's a good thing. Do these things still help us write good programs or better programs, or should we rethink them under the light of modern practice? So, yeah. So this is what we're going to do. We're going to take a look into these things. Maybe we'll keep on thinking the same way. Maybe we'll think differently. Maybe we'll criticize. I don't know. We'll see. So I'm going to take a small set of such advice, a small set, like 3, 4, that we hear, see, and sometimes teach today, and try to, well, at least take a fresh look at them and see if they still hold. So that's the goal. And the first one, of course, is one of the best known ones. Goto considered harmful. You might have heard about that. There's a number of considered harmful papers that have circulated over the years, all inspired by this one, which makes some noise in the past. How many of you have read that thing? Oh, maybe a bit less than a fourth of the room. That's a good paper. You have to go back to 1968, but it's still available. There's Dijkstra archives lying around. It's a rather short paper, really. It's not long, though, like 2 pages. This is an extract, but look at the bold-faced stuff there. So the quality of programmers is a decreasing function of the density of goto statements in the programs they produce, which is quite a harsh statement. You use gotos, you're a bad programmer. Goto statements should be abolished from all higher-level programming languages, so except perhaps machine code, because, well, that's what you'll find there anyway. So think differently, you know? And that kind of seems reasonable. Just curiosity, how many of you have used goto statements, apart from Andre? Well, quite a few still. So do you feel dirty or something? First time I saw one in the classroom when I was a student, I saw people leave the room because the teacher had put one on the board. And the student said, what's that? I said, yeah, it's a goto. And he started like writing code, and people left. They were insulted. It was bad. So I'm guessing everyone can kind of read this thing. It's a while loop that prints numbers from 0 to 10 or something, 1 to 10. And of course, this is not necessarily more readable. It does the same thing, by the way. If you look at the assembly code, it's pretty much the same thing. We can understand someone saying, well, this I can read. This, I have to think about it. Not that much, but still. Yep.
I think there's one reason to use goto,
Label for loops. The question is, why don't we have labeled gotos? Because the proposals for that have not gone through yet. It's been proposed. So some people like it. Java has this, and maybe it will go through at some point, but we're not there yet. You're gonna need to push. And to get your question, if I may, we're targeting the big proposals first these days because some people think that C++17 was too many small things, not enough big things. You might have noticed that C++20 is huge. So you might have a better chance with 23 or 26. But there is a push for that. So let's return to this. So this is actual code that works, but maybe not that readable. And I won't go through the assembly, but you can look at the bold things there. They're pretty similar. Not exactly the thing, but very similar. Now, some people might think, well, I'm going to write goto-based loops. I'm going to be better than my compiler. And yeah, in general, you're probably going to lose. You know, they're very good, those compilers these days. So you can try. Sometimes you'll win, but I'll take the words of a wise man named Jonathan Caves, who works for Microsoft. These optimizations that you might try, they tend to get stale after a while, so revisit your assumptions quite often. So there's many reasons to avoid gotos, like debuggability, it's easier to reason about, teachability, it's easier to explain to people what's going on when they don't have to think about everything. Ease of maintenance, of course. So the point of Dijkstra is to like raise the level of abstraction. You know, think in terms of higher level constructs, which kind of makes sense. You know, structured programming, bring structure into the code, which was kind of Sean Parent's talk focus yesterday. So like kind of everyone agreed, you know, as everyone has read, I think. There was some dissent though. There's this guy you might have heard of, this Noth guy who did a few things in computer science, who's interesting, who wrote a much bigger paper 6 years after, like much bigger, much more substance there. Because the first one was what we call in French a brûlot, it was like shaking the things. So this is a quote, but taking the bold-faced things there. Noth advocates a methodology of program design beginning with a readable and correct, but possibly inefficient programs. So he was thinking about efficiency. Maybe if you do structured programming and the way it was presented, you might sometimes end up with less efficient things that you might like. The efficiency is still important, especially back then. And whether or not goto statements should be abolished, there is merit on both sides of the question. So it's like, it was not saying it's a bad thing to push for more structure, but just that it's not a black and white question. And he had a few points with respect to that. Some of them was, well, in some cases, gotos might actually simplify your code. He was thinking about error management back then. So, and he was thinking also about efficiency, as you'll see. So, yeah, when you have something like this with lots of nesting, which was expressed otherwise, of course, in his original paper from '74, where you have nesting like this, well, if you go this way and you have a test thing there to get out of the loop, it might make the code somewhat more readable, at least according to his interpretation of the thing. Which we would write like this today, wouldn't we? So there are reasonable cases of jumps like that have been formalized in the language. This is one such. I'm not a big user of continue, but I can understand that this might be more left-leaning to take Andre's words from 2 days ago than the other version. I hope you agree. You can have something like this too. That's interesting. So you have the x0 constructor there that's being called. And if the B condition is satisfied, the y0 constructor is being called. If you do something like this, well, you might get surprises sometimes. If you hit the goto test of B there, and you don't hit the closing brace, the destructor of x0 will still be called. So there's a kind of structure. You can kind of avoid the closing brace and still get your destructors called in C++ if the objects have been constructed. So it's not as bad as it could look in the first place. You cannot bypass the destructor with this. Making sense? Okay. This is something that worried me when I started playing with these things, like what happens with destructors, you know? There's an incarnation for that, of course, it's a continue again. So continue is something that we have formalized because there are use cases for this. It simplifies code in some cases if you don't abuse it. This is also fun. So you have this main there, where you have the x0 constructor that's being called, and there's this goto. Well, the constructor is being called 5 times, and this might surprise you, the destructor is called 5 times too. So it's not as bad as it looks. I wouldn't write code like that myself. I'm just saying that it's not as unsafe as people could think. You see that? Okay. Now, please don't do that. Okay. You won't get bit as much as you thought. This is illegal because you might skip the x0 constructor, and that you're not allowed to do. So you can kind of, quote, quote, skip the destructor. It's going to be called anyway. That's like language defined. But skipping over a constructor and adding a chance to access a variable afterwards, no go. So again, yeah, not as bad as it looks in the first place. Still making sense? Okay, and let's say, yeah, please. Yep, it's standardized. There are quotes in the slides if you want to look at them. It's surprising. That's why I went there and I checked, because as you could probably guess, I don't use gotos every day. I don't use them every year. Yep. If you want to look at generated code, you have to check with your favorite compiler. That's really something that's compiler specific and option specific, so please do so. But don't do that. I'm just showing what it does. I'm not saying do that. Please. Okay? If someone gets out of this room saying, Pat says use goto, I'm going to be very angry. This one might surprise you, but it actually compiles. When does it compile? I don't know if you see it. So I'm rolling a dice and saying once every 10 times I might skip something. But the constructor and destructor of n are trivial, and that's actually allowed by the standard. Now, if you have a non-trivial constructor destructor, you're not allowed to do that. That's amusing. Doesn't it amuse you? It's frightening, isn't it? Okay, it actually compiles and it's legal. So Nuth was interested not in this dirty stuff. He was interested in efficiency and in code that makes sense. Okay? So Nuth wanted to exit early from loops. In the original papers, they were saying, well, if you want to look for something in an array, well, do something like this. Get a Boolean result or something, and iterate through things. And when you found what you were looking for, make the Boolean true, and then at the end return something. But as you can see from the slide right now, you're going to go through the entire array, even if you found your answer at the first step. So that's inefficient. You could do it like this also, and check your condition and do for a loop that tests, well, 3 times every iteration. So you're checking your loop counter, you're checking whether you found something, you're doing the n in between. So it's kind of better, but kind of not that good either, isn't it? You will exit earlier, though. And well, in our friend Nuth's perspective, this would be better. I mean, once you found something, get out. Because you have to remember, we're in the 70s, with the machines of the 70s, these things, they did count, and they still count today. Of course, that's not how we would write things today. We have formalized this. So early exit from a loop, it's a go-to. We use break these days, but it's the same idea. It's just easier to read, isn't it? Yeah. So I'm not saying you can abuse the thing. I would just return from this thing personally. So things such as break and continue, well, they are structured using forms of goto. So in terms of structured programming, they are some kind of compromise. But we use them. So we're kind of liars a bit, saying we don't use goto. We cheat. We cheat a bit. So, and the other thing that's probably more important for us is error handling. So as we all know, I think, when you're mixing error handling with real code, the code that does production stuff, well, it gets messy. And it confuses the purpose of your algorithm. So if you're intermingling the two, you're going to end up with some kind of soup of words that's hard to make sense of. And Nuth already knew this. So yeah, you might, if some of you have done Visual Basic 6 or something like that, there was a goto, an error goto construct that said when you had an error at the end of the function. Something kind of like this, This is actually taken from a newspaper, but using another language, of course. So he tries to allocate something, and if you think that you won't be able to, well, you go to some kind of overflow flag or something, and then you do your processing. But the rest of the code, you proceed normally, and you do your allocation. Yay, everything's fine. Today, it would look kind of like this, wouldn't it? The exceptions are kind of a poster child of what structured gotos can be. And you get out of the awkward situations process them in some other location, maybe sometimes outside of the function, why not? And you do your thing normally such that you don't mix the two, and your algorithm actually stays readable. Yeah, why not? So I actually gave a name to those things, those reasonable use cases of gotos. There's, of course, the switch statement, which I'm sure most of you know is a goto in disguise. It's not a real control structure. Right? It's something called goto in Fortran 77. I've done Fortran code in the past. So it's not the same structured programmingness as the other things. It's some kind of weird thing, goto. So if you have this factorial thing that's actually working, it's simple for small numbers, because unsigned long, you have a limit to what you can do with that. You could write it like this, of course, which I probably some of you have seen in the past. Note in the slide how the do and the while interact with the switch statement. If you have never seen this, I'm very, very sorry. You can forget about it when you get out of the room. It's inspired by something called Dove's device, and it was actually a way to unroll loops without resorting to assembly code in the 80s. It still works. It works because switch statements are gotos. So you actually take your the value that you evaluate in this switch I don't know, condition or so, I don't know. You jump somewhere in the middle of the loop, and then you continue, which lets you evacuate the excess case of something that would otherwise be regular, and then you check your condition for the loop less often, which used to make the code faster. Don't do that today. Compilers are much better than this. Okay? Compilers are awesome. But see, it works. And you have that fall-through thing that I put there to avoid the warnings, because since C++ 17, otherwise most compilers will grumble saying, did you forget a break there somewhere? Those taking pictures don't do that at home. Don't do that. When I show this to students, I show this to show them that switch is a go-to, not that it's good practice. And if you look at the generated code, well, compilers will trash you. So it's actually fun. So you look at factorial 5 there. Well, 4 minus 5 modulo 4, which is 1, well, you jump to case 3, and then you just do 2 tests instead of 5 in your loop. Kind of. But loop unrolling, compilers are very good at. But the fact that you can intermingle both shows us that switch is in the scope, doesn't it? Yeah. So amusingly, it's been used in one of Bjarne's papers at Constexpert time to try to implement a replacement for dynamic cast a few years back. When I saw that, I was so surprised. Man, this thing still exists. Whew. In C# it's hard to do this kind of trick because you're forced to put breaks in your code. You cannot skip a break in Java or C# code. But it was pointed out to me by some C# experts that if you really want to do this, you can, using a goto. So the way to have fall-through behavior in C# is to use gotos. So this is actually legal code, I checked it. So I don't know if you can see it. This one, if you pass it a value that takes you to the first statement, well, it goes to the second and the third, and yeah, you get fall-through behavior, but using gotos. So you cannot have that behavior otherwise in C#. I'm very sorry for this. This is interesting. This code compiles. You notice that the switch has no case? It's perfectly legal. So you might get a warning because the X constructor cannot be reached, but it's legal code. I just think it's useful. It's a curiosity. It's standards conforming and everything. Are you still my friends? Okay. This is the same thing. You can do this. You can put a break without having a case statement in the first place. It works. It works fine. It's useless. It's just interesting. It's like going through a shop where there's curiosities and everything. This is actually legal. Compiles just fine. I'm sorry. But this is illegal. This is actually illegal because X would be accessible in the case 1 case, but it has not been initialized because you skip over the constructor. Okay? So I hope this does not make you want to use goto. It's just going around the contours of this thing. Is that okay? Okay. And this is still illegal for the same reason. Yeah, you could, technically speaking, you could access or somewhat, the constructor could exist, the destructor would be called, it's weird a bit. But if you put a scope there, you're okay. So because you're doing like more reasonable code. Still cool? Good. So the extra at a point, structured programming, it makes you read the code better, understand it better. There's like good reasons to do that. And it leads to better code in many ways. I'm pretty sure nobody would want to write code like the last few slides, except like around the beer late at night with people that you will never see again in the future. And Newt also had a point. For efficiency, sometimes you can bend the rules a bit, and there are structured, reasonable ways of doing branches like this that are not the standard if and while set that kind of make your code better. So the break, continue, switch, even try catch makes sense. And break with a label, as was suggested by one of the questions earlier, are under discussion. So maybe you'll get that if that's what you want to get, like respecting the scope rules of C++, which are a bit more complex than Java because of the structures. Okay, so if you want to push for it, write your own papers. Not my thing, but still. And there are things you cannot do with goto statements because you're going to get out to say, I'm going to use this thing. Well, you cannot skip non-vacuous initialization as we saw today. You can skip an int, but not an object with the fancy destructor or constructor. You cannot jump in or out of functions, which makes me feel much better. You cannot use them in const explorer, nice try. And I hope it stays that way. You cannot jump into a try or a catch statement. You can jump out. And the destructors will be called, as long as you respect the other rules. Oh boy. So am I saying use this? No. but use higher level abstractions, of course, but don't lie to yourselves because you're using them anyway. And please, if you're saying, well, if you really want to second guess your compiler, then try to do things that you think you could do better. Well, yeah, measure. And measure often because compilers change. And we don't necessarily maintain that kind of code very often. Revisiting your go-to latent code is not necessarily something you want to do. So measure regularly because, as I said, these things get stale. We're still okay? Okay. So that one wasn't that controversial because the code is scary. So let's go further a bit. This is one of the things, only one exit point per function, that they teach at my school. And I'm of two minds about this. I think I spoke of that earlier in the week in another talk that I gave. When you start with beginners, you take one perspective, and when you go with experienced programmers, there's another one. And when we start with someone who has never programmed, there are kind of ways to think that you want to instill and install in there that are not the same that you deal when someone understands what's going on. So this was also inspired by Dijkstra, but there's something coming up. I always thought it was Dijkstra, to be honest. And you know what's so cool about CppCon? I was at the ESG14 meeting 2 days ago, and I was like doing my secretary work like I always do, and Dan Sachs, a very wise man, comes to me and says, what are you doing this week? So blah, blah. I'm telling him, well, my Friday talk might be weird a bit. And then he says, you know what, where that one exit point per function comes from, the diagram thing that we use to teach that? It doesn't come from Dijkstra. It comes from this guy, Corrado Bohm. He had a proof with the name game, a guy named Jacopin, but I couldn't find a picture of him. Earlier, like in '66, with a proof that you can turn diagrams into programs, and it makes sense. Diagrams are Turing complete if you respect some rules. So I went and read the paper. Very interesting, a bit old, but still. The guy, he died relatively recently. In that paper, there's this piece that says every Turing machine is reducible into, or in a determined sense, is equivalent to a program, written in a language which admits, as for machine rules, only composition and iteration, so structured programming, really. So he's saying if you're doing structured stuff, you can write diagrams, turn them into code, and vice versa, and it works. Pretty cool. When I read about it, there's this thing that says, in fact, that thing has led to the heavy criticism of gotos, which make me smile. But it's cool. So the idea is that if you look at the Dijkstra's paper, if you haven't read it, it's a good paper. There's a formalization saying, well, there's sequences, and there's choices that you make, alternatives, which are if statements, and there's iteration, which all amount to while loops in some form or other. So if you arrange them in some ways, you can actually reason with the program and make proofs about it. So you take complex units that have one entry point and one exit points, and you can compose them together. They kind of look like this. So you have sequence. In the middle, you have the if statement, the true. If the condition is true, you go to the right. If it's false, you go to the left. And there's the iteration that you see on the right of the slide right now. With the condition is the lozenge thing. And you have initialization, condition, processing, and incrementation of your loop counter or something in your loop. And if you notice, each of them has only one entry point and one exit point. And with the proofs that these guys made, if you compose them together, you know, you can make sense out of the code. So it kind of, there's a reason for that. So you have a function, calls another one, which calls another one, and everything. What exit, what entry, it kind of works like Lego blocks. But there are languages where there's not even the concept of a return statement. I've done Pascal for a few years. In Pascal, you write to the output, to the name of your function, and that becomes your output value. And when you reach the end, the last thing you wrote there is the actual return value, but there's no return, quick, we get out. That doesn't exist in that language. At least that didn't exist when I worked with it. So this is a factorial that's recursive, as you can see, and I write to the name of my function every time I go, and that there's a recursive call within the if, and there's no return. I mean, when you reach the end, it's done. The single entry point and exit point is reasonable. Seriously, it helps people reason, which is why I still use it with my beginners. It leads to a clearer train of thought, and they have trouble with enough stuff in programming that you don't want to mess things up more. But it's not always practical. There's upsides and downsides to it. If you look at this, yeah, it's not necessarily pretty. It's a very simple function, I know, but it's not necessarily pretty. You have this variable there. If the condition is true, you put true. If the condition is false, you put false. Then you return the thing. It's a bit long-winded. That's it. This is slightly better because you all say, well, I'm going to be pessimistic and I'm going to assume the result is false, but then I'll revisit my assumption if I made a mistake. I'm going to put truth there. Some people do that. That makes me cringe. Maybe you do that, I don't know. This to me is ugly. If the condition is true, you return true. If it's false, you return false. In this case, the reason for the double return statement is not clear to me. When my students do that, I say, okay, they're not getting it. They're not just getting it. Because they don't understand that the actual condition result that they have is their result. They could just return from this. This is what I expect to make them think about. So in such cases, the single return statement is okay, it leads to better code. I mean, it's clearer, it's simpler, and one-liners like that, they're so much easier to debug than the mess they can make when they start. You know, when there's more than 2 lines, you're gonna end up doing debugging. Yeah. Sean Parent said that, I think. A good function should fit in a tweet. That's pretty much it. Yeah, so here, this is revisiting the case of the early exit earlier, where I'm looping through my array trying to find something. And when I found it, I put some value in my variable, say, okay, I found it. And then I check the variable every time. It's kind of slow. At the previous attempt, I put a break in the code. That's fine. Early exit in this case makes sense too. To me, and when non-beginners do that, I feel okay with it because they got it. They got the answer. There's no point in staying there. Get out. No, break is unnecessary for such cases. It's overkill. Now, there are good reasons to achieve that principle in general, but this might save you from nasty bugs. Now, this is something that I see sometimes. I don't know about you. There's this function there, f, that returns a string view. It's implicit from the return statement that you see in the switch. And there's this enum there with only 3 possible values. An enum class would be better, I know, but it makes for a longer code. And people feel safe because they say, well, there's 3 values, and I've covered all 3 values. I'm totally safe. And if you look at the main statement there, well, the main functions, well, yeah, it looks good. It's where it kind of works. Well, of course, you could pass 10 to the function f, and it compiles very fine in general. You know, it doesn't have to. This one is forced to accept 0, 1, 2, 3. So you could pass 3 and be in trouble already because, yeah, you know that rule? This thing, the smallest power of 2 that takes all of the values. But in practice, you pass 10, it's going to work. So this is ugly because there's a bug in the code. You know, and it might go unnoticed for a while because, well, there's no single exit point at the end. So for this case, it's kind of reasonable. Of course, you could have something like this, eagerly putting a value to return. And so if nothing else worked, at least you know what's going on, or you could throw an exception or something. You could also do it like this with a default if you feel like it, to avoid the superfluous initialization at first. As long as you don't forget the default, you're okay. Making sense? So depending on how you do it, could be good, could be bad, as long as you're very rigorous about it. Um, one good trick, of course, is to write smaller functions. That's one of the reasons I don't use many switches myself. They make for large code. It's hard to reason about. See, if you have simple functions, one function does one thing, the temptation to have many return statements is a bit lower, but it's not always practical. If you look at this, this is a handmade way to compute whether a year is a leap year. Well, it's a bit long-winded, but if you're trying to learn about if statements, why not? You know, it's okay. It works, by the way. You could write it like this, but it's a bit more difficult to grasp, probably. It leads to the same reasoning, but you have to think a bit more about it, don't you? It requires more thought. And you could also actually express it like this. It's not that bad also. But there's the if, else, thens. Not bad. As long as you have the last else at the end, you can kind of see that it will return something at some point. It's pretty safe. But yeah, but I'd argue that this reads well, doesn't it? It reads well. It's okay. So you got all of your cases where you're actually applying rules, and when you get to the end, another rules applied. Well, no, it's not one of them. So get out. I used to think that this was lack of effort, and then when I was working on my PhD code, and I started debugging very complex functions, I realized that, you know, early return is actually pretty nice when you're debugging. Oh, and that brought a change to my mind, saying maybe I should revisit that thinking because I could make better code and enhance my own experience with this. Now, the language has changed, as I was saying at first, so we have new types now. If you play with variant, it's interesting to think about that early return kind of thing, because you can actually have much better code if you're careful. Let's take a few examples. This example is a multi-slide one. It's a bit more complex, but they kind of look the same from point to point. So I'm doing I/O in this case with a message type. I don't know if you can see it up front. There's a message type enum there. And I have functions to write to some stream and read from some stream a value of that enum. So when I'm outputting, I'm casting the thing to its underlying type. I'm going to get some kind of integer. And when I'm reading, I first ensure that my stream is okay, the first if that you can see. And I return early if the stream is in a bad state, because well, why continue? And then I try to read something. I like these new if statements. If, init, semicolon, condition. These work fine for me. They're scopes, they're very nice. And once I have either managed to read something or not, I return the stream. So there's two exits, but that's probably the best implementation that you could get in this case. Same thing there. If you see the two two return statements there, they are highlighted. Same thing with this message info kind of thing, where I'm reusing quoted to read and write. Quoted is nice. C++14 takes care of the quote marks around your strings when there's spaces in them. Takes care of the inner quotes. Awesome. Very nice. You might not like I/O streams, but makes for nicer code. So two returns again, because I'm doing I/O. Why not? That's okay. And again, another two returns with another kind of struct. So this is like regular code. Now, there's no, as I was saying, there's no reason to continue if you're trying to read from a stream and it's corrupted, so just get out. Now, this is where we get to that variant thing. Has everyone seen that overload structure there that we tried to standardize but for 20, but didn't get around to? You can write your own, it's a few lines at most. I'm using a variant in this case with monostate and the two types that might be in the variant. Why am I doing that? Because in the code that I'm going to be using, at first, I'm going to be declaring a variable, at some point store into it, and then return. So I need some kind of default value. And monostate is some kind of empty variant default kind of thing. I don't like that monostate thing. I'd rather it's not there because it's not part of my interface. It's clutter. Okay? But for the fact that my first example will not be using multiple return statements, I'm going to be kind of stuck with it. That's a sign that something's wrong. So my visit in this case is using multiple lambdas. I'm treating the monostate case, but I shouldn't be because it's not part of my interface again. But since I might want to use the other two, and I need some kind of default, well, I have to cover this, otherwise my code won't compile. So I'm kind of making my code a bit dirty because I'm insisting on having a single return statement somewhere, and I have some kind of need for a default, whatever.
Question?
Yep, please.
Can you explain monostate?
It's an empty class that you can use for Thank you. The question from my friend there was, could you explain that monostate thing, literally speaking? So you have a null opt for an empty optional, and the monostate is something that you can use for a default value for a variant when you have many cases, but you don't really want to put default constructors in each of them. So you have something that kind of stands for the empty variant kind of case. Okay. But to me, it's a bit of a hack, because you'd rather not have that if it's not doing something meaningful for you. Is that an okay answer? Okay. So if you look at this case, the reason I'm having the monostate is for the first line that's in bold. I'm saying message, semicolon. So I need some kind of default value. And variants, they initialize the first member, the first type by default, if you do the thing special about it. And then in the cases that I have, if I'm reading an info, I'm storing the info in there. If I'm reading a warning, I'm storing the warning in there. Variants are nice for that. That works. But at the end, I'm returning the message, which might be empty. It might be monostate if I read nothing of value, so the stream was corrupted or whatever. So I'm using that monostate thing there, but it's not really what I want to do. It's just helping me along. And this code could be more efficient because I'm creating a default object that I'm going to replace by something else later on. Default constructors tend to be bad things. Not always, but still. So by enforcing a single point of exit in this specific case, I'm making my code more complex than it should be. And a bit slower also. Yeah. So if you let yourself go without that thing, if you let yourself work with early returns, if you look at the code in this case, I'm returning a message, which you can see from the function signature up there. And when I'm reading a message info and it works, I'm returning an info. And if I'm reading a warning, I'm returning a warning. When I get to the end, in this case, well, I'm returning an empty message, which means in this case, the stream was corrupted. I could also throw an exception or something, like you can see in this case. My friend over there. Okay. The question is, there's this weird line at first, assert not is. So not is means the stream is corrupted. Not is means the stream is doing fine. I leave it there for people to speak about it. So that's it. Yeah, that's it. I'm forcing it to a bool and then using the bool and turning it into a double hash trick. Is that okay? So in this case, I can even do without, if you use the exception as a signal that something went wrong, you can do away completely with the monostate thing. And you can have the variant that only has what you need. So it's more efficient, it's cleaner. Cool? Okay. Okay, no presentation. So if you allow yourself multiple points of exit, some cases, well, you can reduce your code complexity somewhat. You can limit yourself to constructing only the objects that you actually need. Because you know, when you have objects with constructors that are non-trivial, you don't want to construct them without reason because it's costing you processing time and resources and all. And well, you only pay the cost of a default object if it's meaningful in your code. If it's not, why do so? Still okay? So, I'm not saying spread the multiple returns without thinking. The without thinking part is bad, by the way. But if you write small functions, it will occur less often, of course. And it's not inherently bad. It can help make better code, so that's actually fine. You still my friends? Okay, there's no hatred in the room yet. I have colleagues who say data members should all be private. Not this Borg thing. That was a Star Trek reference, I'm sorry. And yes, it's a good thing. I've said that to students for years, to make your stuff private because you don't know what's going on in the future, and maybe something you might want control over it or something. It's actually kind of true, you know. I have this person there that has a name and an age. I'm letting people construct the person with a name and an age if they feel like it. We could validate the thing, that's okay, that's fine. And I'm letting them consult the values without modifying them afterwards, because who wants his or her name to be changed without permission? Oh, don't answer, that would be scary. So this is a fixed age person, an ageless person, why not? So if you put your data members public like this, well, it will still work, you know, but people can access to this. So if you're saying, well, changing the name of a person is bad without his or her consent, yeah, it's not necessarily nice. There are people who used to that with discipline, you know, with languages that are object-oriented without private, public, or such access control mentions in the code. I had a teacher when I was younger, bearded guy, named Maurice, bright person. But the language that he used to teach us object orientation had no such thing as public or private within. So he was enforcing the rules with underscores. So he put underscores just before his variable. But he was a bit of a rough person in the sense that you could say that he spent times in the woods with the animals and everything, but he was a bright computer scientist. Very inspiring. He used to smoke and just besides the no smoking things. And yeah. And I have beer with students. So the guy was nice. And at some point I asked him, why do you put those little underscores like besides your variables? And he says, because you're not supposed to touch them. So, okay. And if you touch them, I'm gonna add another one and another one until you stop touching them. And for string programming through discipline, kind of works. You know, if you say, if you touch this, I'm gonna break the contract until you stop. But it takes time to do this kind of management of source code, so you might not want to do that. So private and public is better, but you know, you can enforce discipline through violence. And this is equivalent, of course. When you have a struct, the data members are public by default. You know? So yeah, enforcing this thing is seen as part of encapsulation because you want to make sure that you can keep your invariants okay. But you know, it's not all types of invariants to enforce. Sometimes they're just data. And I know that most people there are aware of this though. So if you have a like 3 point or something like this, X, Y, Z, and you don't really care what the values of each of them are, there's no specific rules as to where they're supposed to go, you're not tracking when they're changing or something, this is probably overkill a bit. You can just go along with something like this. Is that okay? Yep. Okay, so please allow me to use a phrase I often use with my students. Objects are rock stars. They don't know their children. Okay, so protected is only good in very controlled cases, otherwise it's as bad as public. And it's the honest answer. And this stays here, okay? Nobody knows. Okay. So, okay, when it's protected, it's a code smell. There are reasons for protected, you know, but they're few and far between. If you put protected by default, think about it. So yeah, a case could be made for like, think ahead. You don't know what invariants you might want to add in your code later on, but think about it. If you're changing the invariants of your class once you've pushed them away, you're changing the code. You should probably use another name or something because it's a new class. People have been using the old one anyway, so think about it. So thinking ahead is cool, but putting code in case someone in 10 years might need it, maybe you should think about a new type. Properties would be nice for this, but we don't have them in C++. Yet there are proposals if you want to push for them. So yeah, the trick is to think the design through a bit. So write small classes, document your invariants, and in general, yes, make it private. But if you have no invariants to enforce, probably overkill. And so if you have public data members, you probably have no invariants. Your types are probably mutable, because otherwise you wouldn't be making them public in the first place. And they're probably final, because if you have child classes trying to do things, well, they're going to have to resort to private inheritance to make things work. Making sense? Okay. So just note, because I've had the question before, that these two are not equivalent. You don't want to do the one on top. You want to do the one at the bottom. Do you see that? Const data members, they're legal, but they complicate reasoning in some cases. Your containers need to resort to tricks to make these things work, so prefer the one at the bottom. Okay? And maybe one last one for today, because time flies. Initialize all of your variables. This is so cool. Those who do embedded systems know how wrong this is. Don't you? Because it costs something. And when I had C# programmers trying to learn C++ with me, and saying, why isn't it initialized to 0? Because it costs something. It's just a 0. Have you measured that? So instead of doing the thing that people say, instead of doing the things on top there, and int n, float f, string s, vector, whatever, do the things at the bottom. Is that okay with you? Yeah? Wrong. I'm totally agreeing with you. String s with the quote, it's slower, it's bad. Right? Or you can go for this. Did you like this? Why? No, there's no assignment there. It's a construction. You have an assignment if the variable already exists. This is just a constructor in all cases. It's a default constructor. It's actually equivalent to if you had put the right kind of literals. And the string case is the same as on top.
Get rid of the equal sign.
You can get, are you saying this? You read my mind. So, but I like personally the brace thing. It works for me. I know it doesn't work for everyone in the room, but it works for me. But don't do it like this. Because some people, sometimes, if you do int n equals int per n, it brings 0 to your int. So you say it's going to be the same thing as int per n, and no. Replace the n with an f and you'll see it right away. So don't do that. Yes, my friend?
I'd argue the string and vector is still wrong because they're default constructors. While the
In this case, you mean? It's the same thing as vector of x v semicolon. Same thing.
it's redundant.
Yeah, if you're doing generic code, it's fun because you have a generic solution, though. But yeah, it doesn't bring you anything more. I actually agree with you. So if you're doing specific stuff with vector, you have lost nothing, but you have gained nothing. It costs you 2 characters. If you're doing generic stuff, well, you have a solution that works for everything, so it's kind of neat for that. Okay, depending on what you want to say, of course. But I'm not saying to do that. I'm saying it's a myth. Okay, so don't do this. And this actually works, which is what you have in mind, I guess. So your int is default initialized and everything, blah, blah, blah. So, but do you always need to initialize everything? Well, I'll argue that in most cases, no. No, because there's many, well, of course, if you are ready to construct your object because you know what you want to put in it, it's the time to do so. You know? But there are costs to that. So, this is probably easy for you folks. There's a distinction in C++ between declaration and definition. You can repeat declarations, you cannot repeat definitions because there's something called the ODR that will bite you. And it has big teeth. No, you haven't seen the ODR? At night. Be careful. Something. So you have to be careful with this. So the code that you have on top is C# code which doesn't compile because you're declaring n without initializing it. Conceptually speaking, it has 0 in it, but you're not supposed to know about it. And then you're doing a write line to put that thing on screen, and it will tell you, no, you have not initialized your variable. But funny thing, if you look at the code at the bottom, there's this array there. You have not initialized the ints in the array, but because you did new, it has 0 initialized everything, and it works like magic. Which makes me feel very bad. So if you're doing C++ and you look at the code that's on top, well, someone has put 0 into n. Why? Because it's supposed to be done that way. And then reading into n, which kind of is making the initialization probably redundant, unless, of course, you're using n even if the reading has failed, which can be kind of weird. You could do the middle thing, uninitialized, and then write to it. Of course, please don't use the n if the reading has not worked in the else statement. Or I think even better, the one at the bottom, which scopes the n and the if and removes all of the problems. Is that okay? Scopes are cool, aren't they? Yeah, let's scopes. Cool. So yeah, so the point of this principle, those who use it, it's because they don't want to leave uninitialized data around. But that comes back to the time when people wrote very large functions, put their variables on top, and use them lower, doesn't it? It's been a while. Like smaller functions, better code gen, and code that's initialized at the right moment, better code gen. So that's cool, C++. So this tradition of having declaration and then initialization, it still makes sense when you're with beginners and they have to think about the code that they don't know what's going on, but that will experience people, it's not a good thing. So if you initialize things, that's not necessarily bad, you know, but you don't have to if it doesn't make any sense. And if you're not sure, did I initialize that variable or not, your function is too big. Maybe there's 2 functions in there. So the code that I put in my friend function there that's trying to read data for my person is initializing a string and declaring an age, now defining an age. Now the string constructor is costing me something, not much, but something. The short constructor is not costing me much. And if my stream is feeling bad, I'm getting out. Why the hell did I declare my name? Seriously, what's the point? This is better because I'm declaring the string only after I know that I might be in the position to use it. Making sense? It's not as wasteful. The age is a bit like early, but it's trivial, so I don't care that much. And this is a bit better also, because now my name is scoped by the if that uses it. It's not used anywhere else. Cleaner code, no? Nicer. Is that okay? Note maybe one thing, in the if statement, I'm initializing p in one statement because I don't want partly initialized variables. You know? If you're trying to read directly the name and then directly the age, and if the reading of the name works and the reading of the age fails, you have an uninitialized in part object, and that's not fun. So don't do that. Is that okay? Cool. Or this could be better still if you feel like it. You can have nested ifs and have shorter scopes. But again, with the short, it doesn't do much. Is that okay? Cool. When you really, really need to do two-step initializations, instead of leaving it in the while, you can write it to factory functions. We can actually make them very efficient in C++. So, well, don't stop yourself from having fun. This avoids leaking the initialized objects into client code. So if you know that you shouldn't be having an empty object in your code, but you do need to do like I/O like this, so you're going to have to declare an empty object at some point, and it's going to be nasty a bit, encapsulate that. Don't let that leak out. So I have this two-step thing there. There's an init function that really needs to be called for some reason. And the default constructor there might not be something that I want to expose to client code, I put it predicted in this case, but I have a friend that does this create two-step thing. That one I control, I deliver with the same files so that nobody tries to hack me or something because people are bad. And then create two-step in a control environment. I can do my uninitialized thing, you know, because I control the situation and it will not leak outside as uninitialized data. And then I init it and then I return it once I'm done, and that's pretty fine. So in main, when I create the thing, I get it fully initialized and that's okay. Making sense? Like this, to get the named RVO effect that you might probably want if you went to Ben's talk yesterday. Cool? Cool. There. So even in other languages, it's not a good practice anyway. This is Java code, if I'm not mistaken. There's this make function there that will create an X at some point, whatever. And there's this use X thing that has an X, and at some point initializes it with make X. Don't declare when you're ready. That's it. Okay? Otherwise, you have something floating about. There's no reason for that. That's bad. Still cool? So yeah, the usual tricks apply. So think before you code, rather write small functions. You'll be happy. Declare objects when needed and where needed. Yeah, and keep your objects close to point of use so you'll have less garbage lying around. And if you have small functions, that's a no-brainer. So, because I don't want people getting out of the room saying, use gotos. No. Avoid gotos unless you have a reason that you can measure for. It's not that dirty, but it is a cold smell. So we've looked at it. We look at code. It works. We know the ins and outs. And we still feel bad, so that's a sign. If you don't feel bad, we have to talk. But not today because I have a plane to catch. So keep your code at a higher level abstraction. It's easier to reason about, easier to understand, costs less to manage. Multiple returns are not that bad, but if your functions are small and their role is clear, you will need them less. And make sure you document your reasons and you don't leak stuff. So don't do it for laziness, do it because you have a reason. If there's a reason, that's cool. If you think about things. Recipes are bad if you don't think about things. And no, you don't need to initialize everything. But it might be a good reason. You have to be careful. Sometimes it's wasteful. You're just wasting code. Why waste code? So you define them when you need it. And if you need a two-step initialization thing, well, we have RVO and then RVO. Write a factory function. They're efficient in C++. And no, you don't have to make everything private, but it does ease refactoring. It can make your life easier indeed. But if you don't have any invariants, you don't have to feel that dirty that you didn't make it in the first place. It's okay. So I hope it consoles you, and tonight you'll sleep better if you do something like this in a documented manner. I have a number of other slides, but we won't have the time to go over them. They will be put there because there are other performance-related myths at the end. So if you want to pick the slides after the talk, of course, feel free to do so and play with Godbolt and use the code examples and everything. But in the meantime, if you want to go with threats or anything, now's the time. Oh, Mr. Summerlab.
Patrice, this summer we had the Misra C++ work group where we figured out that the single entry, single exit principle that comes from safety guidelines has the same sources that you cited, but we came to a different conclusion. It's about structured programming, and return is a structured programming term. The function will always return to the call side if you return, regardless how many returns you have in your function.
Yeah, I agree with you.
So it's perfectly not violating the single exit principle by just using multiple returns, because you return to the same place.
I so agree with you. My point, I think, was that people still teach it as something good, but it comes from another era. And now we have objects, and we have constructors, and this is wasteful. So as long as you make sure that you've gone through everything and you have good tools to validate it, it's perfectly fine to do so. As long as you're not just lazy and just doing bad code because you can do it.
Well, short functions are helping.
Short functions make everyone happy, and you don't debug much. Matthew.
Hello. 2 years ago, Kevlin Annie made a talk about structured programming at HCCU, if I remember correctly, in which he talks about multiple returns. And he argues that multiple returns are acceptable as long as you keep an else-if branch afterwards, so that from top-level readability, you can still see the flow of the function without having to go all the way to the end of the line to see that there's actually a control breach.
Yeah.
Do you agree with that?
Well, you want to make sure that there's no way to get out without a problem. If you have your default case in your switch, you're okay. To my surprise, when I ran tests, some C# compilers do this wrong. There's no way to get out of the function without hitting something, but it sometimes don't see it. It's not as I thought it was a solved problem, to be honest, and I realized it's not. Compilers are not always good. Our C++ compilers are good at tracking this. But yeah, and there's the weird case of unreachable code sometimes that you want to get out or whatever. But yeah, I agree with you. As long as you have a clear way to say that, yeah, there's no way to get out of my function without initializing something, that's pretty good. Yeah. I'm for it. But as you can see, I do it now. I think it's a good thing. It leads to a better debugging experience. But as Peter was saying a few seconds ago, smaller functions are so much simpler to reason about.
They are. Thank you.
My friend.
Hi,
Andre, hey, glad to meet you.
Same here, and thank you for an inspiring talk.
I didn't expect that.
It really is, and
okay.
it inspires two comments that I would like to make here. One, about leaving the variables uninitialized. I would add to your list that it may be even safer to leave it uninitialized.
Yeah, true.
Because
sanitizer will catch them.
Yeah, because then sanitizer will help you, and it will not help you if there is a language that puts zeros inside, because
and
now maybe you wanted that.
I remember reading that in your blog. But I agree with you. If you leave them uninitialized, that's you have a better chance of catching them through undefined behavior sanitizers. Yeah, true. And your other comment was?
The other is about goto.
I'm sorry.
It's about a goto.
Yeah, no, I'm sorry that I put this on the slides.
Okay. So yeah, I agree with your conclusion that you should avoid it unless you shouldn't. But you give an example where you might need it for performance. I find that I sometimes need it for clarity of the code.
Interesting.
So yes, in 99% of the cases you usually have an abstraction that does it better, but there's always this 1% where goto just gives me the clear code.
Well, there's clearly a reason why the programming languages keep it in.
Yeah, that's probably so. And then I'm uncomfortable because many people will tell me, no, you're doing it wrong. Try stuff anything else, do messy code, but not goto as a principle.
But we agree it can get convoluted in such cases, can't it? So sometimes indeed, if you know the scoping rules, the sorters will be called and everything, it's not that bad. Even Python has goto. Thank you.
Thanks.
My friend, maybe one last one because it's getting late. Yeah.
Thanks for talk. Since we're talking about some contradictory topics, I'm a little bit concerned about partially initialized objects when you read from stream and stream is broken in the middle. So what's wrong with the partially initialized object when stream is broken in the middle?
Okay, so I could code you an example if I had the time. So the thing is, if you're getting an object and you're reading from a stream, and you're not careful checking that the stream is okay after doing your read, and you have a halfway initialized object, in your code, there's something lying around that's not correct. It's not encapsulated in the sense that its invariance might not be respected because you overwrote part of it, it's not complete. So you have something that's hard to reason about because it's halfway done and halfway not done. If you have things like that in your code, you're doing things that might be legal, but if you cannot use the object as an object. So normally what we try to do when we have constructors is that when they fail, we make sure that the object doesn't exist, we throw or something like that. If you're doing something like this, you have an object that's wrong, but it's still in the code, so you have to be careful.
So you say that if the object is partially initialized, but it's still valid?
Only you know that. Only you know that. But that's something
Yeah.
different. Now, if you have a default constructor where you read part of the object and you know that the things that might have been messed up are not that bad, that's okay. But think about it. If you read an X and a Y and you didn't read a Z, does your object make sense? It
Well,
might be usable, but does it make sense?
Of course it's broken, but the stream is broken, so I'm already in a fault state.
Yeah, indeed.
And I'll just drop this partially initialized object and it will be safely destroyed.
Yeah. If your color code is if object declaration, semicolon, read the object, use the object, you're safe.
Okay, thanks.
Anything else? Thank you, everyone.